Hello everyone, welcome again. Why don't we use aeroplanes to go to space is a topic which I'm going to be talking today. So you all may be wondering, why don't we use these aeroplanes to just jump into space and come back? Now here's the thing, that aeroplanes work on air, meaning that the engines are adapted to only work when there is air, and if there is no air, then the aeroplanes won't fly. If you want a brief discovery and invention about these aeroplanes engines, please check out my last video. So aeroplanes engines will be like a funnel shaped, two-stage funnel shape. Here the little sucking portal is a big fan. I hope many of you have seen the aeroplane's fans through which the air enters, and then there's a combustion chamber where hydrogen fuel is released and it is burnt and gets out through a nozzle, expanding nozzle. So this is how aeroplanes work. So without air, there is no aeroplanes flying in the skies. This is the main reason that we don't use airplanes to go to space. But in space, there's vacuum, there's no air, there's no gases. So the air won't be rushing into the engine and coming out. Therefore, there are rockets which use fuel in them and burn them out instead of getting fuel from the air. So this is why we don't use airplanes to go to space. What would happen if we actually used it? Then the airplane, let's say this is the starting point of the airplane. It flies up to a height of 300 meters. And from there on, it is full of vacuum. From here to wherever, it is full of vacuum where the airplanes won't function and they'll just drop onto the ground. So this is the main worst scenario, because that we don't go to space using airplanes. That's why we use airplanes to function around Earth's atmosphere, so that there will be air enough for the airplane to move. And when you rise up in the atmosphere, the airplanes will start to go slower because there will be lesser air rushing through in, because most of the air there will be cold. Now let me discuss why does airplanes in the air that is very high above go slower than the down areas in the Earth. So first case is that in the high altitudes, there will be less temperature, let's say minus temperature sometimes. And in the lower areas that is on the earth, land, there will be normal air rushing around, wind going, and therefore the wind level will be really high. Now I'll explain the scenario in a graph. Let's say this is sea level, that is S. And from here, the height increases with a kilometer. This is 2 kilometers, 3 kilometers, and so on. So here is the distance covered. It goes like this towards the time x-axis and y-axis. So how do we measure this? This will be the air intake. Air intake. As we increase the height, there is a distance, the air intake will become lesser, because in these areas, which is the height of these kilometers, that is 3000 meters, there will be cold air. As we increase in the altitude, less air. There is colder air, damper air. The cold air will be a steady molecule, like they'll be compressed instead of contracting. Because of this compression, the air won't be rushing again. With this, we can conclude that the colder air will stay still and the warmer air will be rushing around. So the distance between the intermolecular gaps will be very high, whereas in the cold areas, the intermolecular space will be very less, so that the air won't be just enough. So the airplane gets slower and slower when it reaches a very high altitude. So with this, we can conclude that the air pressure, A is air and P is pressure, it is proportional to 1 by volume of air. So if the pressure of air is high, then the volume of air will also be high. Meaning that if the pressure of the air increases, the volume of the air will also increase. If the pressure of the air decreases, the volume of the air will also decrease. I hope you enjoyed the video, and thanks for watching.